Hello everyone. So welcome to one more video on Thevenin's theorem, and we are solving series of problems, on this particular subject. How to apply Thevenin's theorem and solve the circuit problems in DC networks. So this is a part of the playlist, and for the time being, this is kind of the last video in the playlist. Now in future I may add more videos in this playlist, but for the time being this is like a practice for you. Now I have been showing a lot of problems, example problems, in my previous videos, previous pages. A lot of things are there. So if you are directly coming to this video for the first time, please go to the my YouTube channel, search for the playlist with the title Thevenin's theorem, and you will find a playlist and you will find a series of videos. First you finish those videos, and finally you can come to this particular video where we are going to solve this problem. In fact, you can solve this problem without using pen and paper, just by observation, and the solutions are also available here. Okay, so if you see A, B, C, D, E, F, 6 problems are there. In all the problems A, B terminals are given. So the objective is to find the Thevenin's equivalent circuit for all these 6. Okay, so and the Thevenin's equivalent circuit will have VTH and RTH. So here like this the answers are given. Okay, so answer to the first one is 8 volt 6 ohms, 120 volt 6 ohms, 12 volt 6 ohms. Fourth one D, that is 12 volts 20 ohms, minus 40 volts and 5 ohms, and minus 12 ohms and 30 ohms. So anyway, so now what I want you to do, you know the answers, right? You can pause here and copy the answers, and you have the circuits also. You know the circuits, you know the answers. Just pause the whole thing and mentally try to calculate RTH and VTH without using any pen or paper or calculator, whatever. And then you can verify with this. Okay? So that is the challenge. If you are unable to do it, then okay, it's all right. Take a pen and paper and try to solve it, and then again match your answers with what is displayed on the bottom. So I will also be doing the same here, but if you want to try it yourself, this is a moment where you can pause. Okay, now let me work out these solutions. Okay, so let's look at the first circuit. Okay, so in the first circuit, what we have is this AB terminals, and we have like this. So how to find RTH? So short circuit the 12 ohms, 6 and 3 will be parallel. 6 and 3 parallel means 6 into 3 divided by 6 plus 3. So this is 2 ohms. 2 ohms is in series with 4. So that is the Thevenin's resistance. So 4 plus 2, 6 ohms. So here we have 6 ohms in the answer. So this we got correct. Next, Thevenin's voltage. Okay, so now when there is nothing connected between A and B, the current here will be 0. So what will be the current here? So 6 plus 3, these two will become series. See, just some time back I said 6 and 3 are in parallel. See, 6 and 3 are in parallel when you are looking from the perspective of AB, like this. But 6 and 3 are in series when you are looking in this perspective of this circuit. So 6 plus 3 is 9 volts. Okay, and 9 ohms and 12 volts. Okay, so again you apply potential divider principle. So here you will know that this will be 8 volts and this will be 4 volts, because the voltage will be proportional to the resistance value. Okay, so 6 is double of 3. Similarly, 8 volt is double of 4 volt, and 8 plus 4 is 12. Okay, so here the voltage is 8 volts. So the Thevenin's voltage between terminals A and B will be 8 volts, because we are going upwards and the current is going downwards, so plus 8. Okay, so again you see the answer here, 8 volts, it is matching. So first one is solved. Now let's look at the second one. RTH, Thevenin's resistance. So looking from this side, this will be short circuit and this will be open circuit. When this is open circuit, 6 parallel 3. 6 parallel 3 is 2. 2 in series with 4 is again 6. Okay, so exactly the same calculation. We got the Thevenin's impedance for the B circuit or second circuit is 6 ohms. Now reintroduce this 100 volt source and reintroduce the 10 amperes current. Okay, so here current will be 0 because B is open circuited. Here current will be 0 because A is open circuited. So all the current, whatever this 10 amperes is there, will be divided among 3 and 6. But let's not even worry about 3 and 6. let's replace this 3 and 6 with the equivalent resistance of 2. So if the equivalent resistance is 2, because 6 and 3 both are in parallel, it will carry 10 amperes. So 2 ohms carrying 10 amperes will be 20 volts. So 20 volts, this one is high voltage and this one is low voltage. So now how to find the VAB? KVL from B to A. So from B you go minus side to plus side, you increase by 100 volts. And here I said it is already 20 volts. So increase by 100 volts and increase by 20 volts, so 120 volts. And here the voltage drop is 0. So by the time you come to A, so voltage of VAB is plus 120. Plus 100 here and plus 20 here. So plus 120. Okay, so that's exactly what we are having here. Now coming to the C problem or third problem. So again exactly same, 6 parallel 3. This is short circuited. 6 parallel 3 is 2 and 2 in series with 4 is 6. Okay, so again you find that it is 6 ohms. Okay, so here you can find 6 ohms as the answer. Now the question is how to find the Thevenin's voltage. Okay, so now reintroduce this voltage. Now the current here in the 4 ohms will be 0 and there is no voltage drop here. So now all the current, now here 6 and 3 will become series. So total resistance is 9, total voltage is 36. So 36 divided by 9 is 4. So 4 amperes of current is going up, going left, and 4 amperes of current is coming down. So 4 into 3 is 12 volts. So if I start from B to A KVL, I come here, 12 volts is increase in my voltage, and then there is no voltage drop in the 4 ohms. So finally VAB is 12. Okay, our Thevenin's voltage is 12 volts. Okay, so that is exactly what the answer is given here, 12 volts. Okay, so we solved the first one, second one and third one, A, B, C. Now let us solve the D circuit. Okay, so what is the first objective now? This is short circuited. Okay, so and between A, B terminals I have to find the equivalent impedance. So when this part is short circuited, so you will see here current is dividing into one branch 10, another branch 10, and then again they are connecting back. So 10, 10 are in parallel. So 10, 10 parallel, it will be 5. That 5 is in series with 15. So the Thevenin's resistance appearing between terminals A and B is 20 ohms. Okay, so that is what here it is 20 ohms. We got it. Next, Thevenin's voltage. Okay, so now reintroduce the voltage 12 volts. There won't be any current in this branch and no current in this branch. So only current will be in this branch. And we don't even have to solve that current because 10 and 10 equal. So it will divide 12 and 12 equally. 12 volts here, 12 volts here, because these two are only thing in the circuit and 24 volts is given here. So here it is 12 volts. So the VAB is nothing but plus 12 and that is nothing but VTH. Okay, so that is what here we have the 12 volt. Okay, so we solve the D also. Now let us work out the this circuit. Okay, so just again you can pause, take a moment, look at this circuit. I will be solving it. So first resistance. Okay, so Thevenin's resistance between A and B. So looking at A and B, short circuit this part and open circuit this part. So when you open circuit this part, 4 and 12 will become series, sorry, parallel. So 4 parallel 12. So 4 into 12 divided by 4 plus 12. So 4 into 12 is 48. 48 divided by 16 is 3 ohms. Okay, so the total impedance resistance here is 3. So 3 plus 2 is 5. So total resistance between A and B is 5. Okay, so here we got 5. Now what is the voltage? Okay. VAB. So VAB means we have to apply the Kirchhoff's voltage law from B to A. So before that, let's solve this thing. See, we already solved that 12 and 4 are parallel with each other, right? So even if the current source is introduced here 20 amperes, still 12 and 4 are in parallel with respect to that. So effectively it is 3. So simply forget this 12 and make this 4 into 3. That's it. It will be same. Now 20 amperes go up and it cannot go into A because it is open circuit. So 20 ampere will go left into that imaginary 3 ohms resistance and again comes back. So 3 into 20 will be 60 volts of voltage drop. But here the current goes up and then this side the current coming down. Okay, so this is high potential and this is low potential. Okay, so remember that this is plus and minus, and the drop here will be 60 volts. Now apply Kirchhoff to find the Thevenin's voltage. VTH is nothing but VAB. It's nothing but KVL from B to A. So you start from B. First you hit the positive terminal, then you go towards the negative. That means you are losing 100 volts. So minus 100. Then here you are gaining 60 volts because the current is coming downward. So minus 100 plus 60. That means minus 40. And here there is no voltage drop because the current is 0. So minus 100 plus 60, nothing but minus 40. And that minus 40 is what is here. Okay. So this is little bit tricky, needs a little bit imagination, but I hope you got it. Now finally let's look at this. So again find the Thevenin's resistance looking from these two terminals AB. So this is short circuited, this is short circuited. 60 parallel with 30 will be 20 because 60 into 30 is 1800 and 60 plus 30 is 90. 1800 divided by 90 is 20. See, one thing is the equivalent resistance will be lesser than both of these. Okay, so lesser than 30. So that will be 20. Now why I calculated 20? Because I want to know the current here. Okay. So, or in other words, see, this is my only circuit, right? This 24 won't have any current and this 10 will not have any current. How this 36 volts will be divided among these two? Potential division principle. So this 36 is nothing but 12 into 3 is 36, right? So here it will be 12 volts, here it will be 24 volts. So 12 plus 24 is 36. Okay, that is how. So now I know that this 30 ohms has a 12 volts drop, which is going downward. The current will be going downwards because this side is plus. So now I start the Kirchhoff voltage law from B, 0. By the way, impedance I did not calculate. Anyway, directly I am calculating the Kirchhoff voltage, the Thevenin's voltage. So from B, nothing, no drop here. And here it is 12 volts I calculated. So from here to here if I go, I gain 12 volts, so plus 12. And from here, plus towards minus I lose 12 volts. So finally by the time I go from B to A, I have achieved minus 12 volts. So that is the Thevenin's voltage. Next, impedance is easy. 60 parallel 30 is 20, 20 series 10 is 30. Okay, so that is what is 30 ohms. So now we got all the answers correct. So the point is, conceptually, if you are very clear about how these circuits get connected and interconnected, then most of the problems they try to test your concepts. So most of the problems in electrical engineering would be of this nature, where you don't need a very complicated calculation. But of course there will be several problems where you need to calculate up to third decimal place and fourth decimal place. That is a different kind of test, whereas this kind of problems are different kind of tests where they are trying to understand your conceptual understanding. But anyway, if you say that I don't want to trouble my mind so much, I just want to for everything I want to solve it, so that is also a very easy way. You just simply solve it and you will easily find. You put pen on paper and find all the branch currents and then simply calculate everything, and then you will be easily able to do that. But if you are able to do without writing anything, just looking at the diagram and then coming up with this, then it is good. You got some more grip. So I think I will, for the time being, I'll conclude this particular playlist on Thevenin's circuits applied to DC networks. And in future, if I take up any AC networks, then I will add more videos in the same playlist. But for the timing, I hope this was helpful. Look all the videos from beginning to ending in this Thevenin's particular theorem. And this is a very interesting and useful theorem in the basic electrical engineering course. And in fact, Thevenin's theorem is one of the fundamental theorems in the electrical engineering. So you should be aware of this. Not only this, you go online, search for sample problems on Thevenin's theorem. You will find several problems online. Just go for Google images search and search for Thevenin's theorem. You will get some example problems. Try to solve it. By the way, the source for this particular diagrams is a textbook called Electrical Technology Volume 1 by B.L. Thereja and A.K. Thereja. and it is from H. Chand Publications. Okay, so if you just search online, Electrical Technology Volume 1, B.L. Thereja, Thereja. Now they have volume 1, volume 2, volume 3 and volume 4. 4 volumes they have, and very nice. When I was student, I was learning, I used the B.L. Thereja book only. So that's why for you I am making these videos by picking up problems from that same book. Anyway, thanks for staying up to here patiently. So I hope you learned Thevenin's theorem from this, and hope to see you in some other playlist on some other topic very soon in this particular channel. If you like this video, please press the like button. Please refer my channel to your friends, and I'll be making from time to time several videos on coding, on electrical engineering, and even on subjects like accounting and something related to research and R&D work. Thank you so much. See you in some other video.